Okay, so as in the last video, we have tried the formula for finding the acceleration of a projection of a particle which is moving along the uniform circular path, right? We know that acceleration of a shadow is equal to the x component of the particle's acceleration, so we made both equal. AQ is equal to minus APX, and we know that when we remove this x, we're going to have cos theta, so minus AP cos theta. With that, we were also known that the centripetal acceleration in the uniform circular motion is minus, not minus, however, omega r square. So we have just substituted r omega square in this formula. We have got AQ is equal to minus r omega square cos theta. We have just rearranged this minus omega square r cos theta, right? So we were already known that r cos theta is equal to x, since we have already derived the formula for the displacement of a particle, which was x is equal to r cos theta, not particle however projection. So instead of r cos theta, I have put x. Finally, the formula for finding the acceleration of a particle, we have got minus x omega square, minus x omega square, right? Now in today's video, we are going to discuss the maximum acceleration and the minimum acceleration. The minimum acceleration, the maximum and the minimum acceleration. Where you're gonna find your maximum acceleration? You're gonna find your maximum acceleration at extreme position. At extreme position, right? And where you're gonna have your minimum acceleration? At mean position. We know that at mean position your displacement is equal to 0, right? Or you can write general formula for acceleration first. So formula for finding the acceleration is what? A is equal to minus x omega square, minus x omega square, right? And we know that at mean position we have minimum displacement, which means our x is equal to 0 at mean position, right? So A is equal to minus, instead of x we can put 0 omega square, and anything multiplied by 0 is 0. So we have got our minimum acceleration, where at mean position because of displacement 0, because of displacement 0, right? Now let's do the same for the maximum displacement. Let's write the formula for it first. The formula for finding the acceleration is what? A is equal to minus x omega square, minus x omega square. So now you can put, we will gonna know that x would be equal to here x naught, or you can say x would be equal to amplitude here, since this is the maximum displacement, right? Or you can put your x is equal to r2, then you're gonna substitute your value here in this formula and you're gonna find your maximum acceleration. So we have now studied the minimum and the maximum acceleration as well. In the next video we will gonna start our second example of simple harmonic motion. We have already studied now the first example, which is the motion of a projection of a particle along the uniform circular path, or you can say the connection between uniform circular motion and simple harmonic motion. The second example would be about motion under elastic restoring force, motion under elastic restoring force, or you can say that is Hooke's law, where we're gonna study the mass spring system. So that is very interesting topic too. We're gonna drive each and every formula for it. We're gonna introduce you to the time period, frequency as well. So this was all for today.